Good morning, students. Today I'm going to tell you the image formation concept by a convex mirror. So, again, in the case of convex mirror also we are going to take the same three rays that we took in the case of concave mirrors. One ray which is coming parallel to the principal axis. It will be passing through the focus after reflection. The ray which comes through the focus, it gets parallel after reflection, and the ray of light that comes through the center of curvature, it goes back in the same path, or it retreats the path. Now this is our convex mirror. Its outer surface is reflecting and the inner surface is polished with silver. And here we mark the center of this mirror as pole, right? Now because the outer surface is shiny one, so that means the focus, the center of curvature, all will be towards inside. So that means if we take the distances again 2 centimeters from the pole, 2 centimeters is our focus. From the focus again further 2 centimeters at a distance of 2 centimeters is our center of curvature. So this is our center of curvature, this is our focus, and this is our pole. And the line passing through the pole and center of curvature is called the principal axis. I hope you are familiar with these terms now. Now, in this case, what we are going to do, we are going to keep an object in front of the mirror because this is a reflecting surface now. So, when the ray comes parallel to the mirror from the tip of the object, because here it strikes with the mirror and it gets reflected. It goes here. Because now it can't enter. It can't enter the mirror. So it gets reflected from the surface itself. Okay. And then we produce it backwards. Because it's not actually passing through the mirror, but we are extending it backwards behind the mirror. Right? Now, the ray which comes through center of curvature, here is the center of curvature, and here is the tip of the object. So we have to draw a line here now. The ray which is coming through center of curvature, it will retreat its path. So if we see clearly, these rays are meeting at this point. Okay, so that means this is the point where the image formation is going to take place, and this point is, you can see, on the principal axis. So the image is going to be virtual because the lines are not actually meeting, and it is going to be erect. So if we see the image of the object, it is very small in size, very diminished, and it is erect and it's virtual because the lines are actually not meeting, but we are making them meet. So they are appearing to meet between focus and pole. So the lines or the rays are meeting after reflection at a point between P and F, and they are appearing to meet behind the mirror. That's why the image formed is virtual, erect, and diminished in size. So let's think of another condition. Let's move the object little closer. So again we have a convex mirror over here. We mark the pole of the mirror. We draw the principal axis of the mirror. We mark the focus and the center of curvature. Focus and center of curvature. And we bring our object a little closer to the mirror. And then again we start drawing the rays of light which are coming from the object, striking the mirror. The one which is coming parallel to principal axis. After striking the mirror, it goes back. The one which comes through the center of curvature. It repeats its path, and if we produce that ray also, so So these rays are meeting here now, and again the image formed is erect between F and P, right? And it is smaller than the object. But if we see the difference of the sizes of the images between these two diagrams, when the object was little far from the mirror and now the object is little closer to the mirror. So if we see the difference in the size of the images, we see that though the images are smaller than the object, but still the size of the image has little increased a little bit. So that means in the case of convex mirrors, the image formation will always take place between P and F, and the image will always be virtual. It will be erect, and it will be smaller than the object. But as we move the object closer to the mirror, the size of the image will start increasing. It will increase in size. That's the only thing that we have to learn here. That as we move the object away from the mirror, the size of the object image becomes smaller, and as we move the object towards the mirror, the size of the image becomes bigger. But the size of the image is always smaller than the object. So these things you have to learn for the convex mirrors. You can try on your own to draw these diagrams so that you can practice it well.